Next, I'll teach you another method for horizontally expanding tables, called left and right join. This feature achieves similar results to adding columns from other tables. But it offers more options, including left join, right join, full join, and inner join. If I say it's like the SQL join, you might understand quickly. But don't worry if you haven't learned SQL, it's not complicated. Once encapsulated in FineBI, it's actually quite easy to learn. Before we dive into the details, we first need to define the concepts of left and right. Let's define the table we're currently editing as the left table or main table. The table from which we will add fields is called the right table. Now that we have defined the left and right, let's ensure we are on the same page. In the examples we'll use, the merge criterion will always be the named field, which is the only field we use for matching. Let's begin with the left join. Here's the difference between the left table and the right table. The left table is a grade table, which includes each person's name. The right table is a student dimension table, which contains sex, class, and age. Notice that the key difference here is the merge criterion field, the name field. In the right table, there's a Zhao Lei, and in the left table, there's a Chen Yi. And these names are unique. In a left join, we guarantee that the left table's merge criterion field remains complete. What does that mean? Let's look at the result. After merging, the names are only Li Ming, Su Min, and Chen Yi. The students from the left table are all there, but Zhao Lei from the right table is not. This is what I mean by the left table remains fully intact. In the merging process, since Zhao Lei could not find a corresponding match in the left table, he is excluded from the result. Also, Chen Yi's information is missing from the right table, so there will be empty values for Chen Yi. A right join is the opposite. In this case, the right table's merge criterion field is guaranteed to be complete. As a result, Zhao Lei will be included, but Chen Yi will not. The third type is the full join. You can think of this as the union operation in mathematics. It's essentially a merge where we take the union of the merge criterion fields. We can see that Li Ming, Su Min, Chen Yi, and Zhao Lei are all present, everything is complete. The fourth type is the inner join, which corresponds to the intersection operation in mathematics. The result will only include the records that exist in both tables and match on the merge criterion. In this case, only Li Ming and Su Min will appear. Chen Yi is missing from the right table, and Zhao Lei is missing from the left table, so they are excluded. For left and right join, the merge methods are fairly easy to understand. One common issue you may encounter is a warning like this. The merge criterion in both tables contains duplicate values. This could lead to data expansion and errors. So, what is this data expansion? Let's take a look at the following example to understand it. The left table is a student dimension table, and in this case, both Class 1 and Class 2 have a student named Li Ming. So there are 2 rows for Li Ming. The right table, for clarity, only contains the Chinese language score. And again, both Class 1 and Class 2 have a Li Ming with Chinese scores. Now, if we only use the name field as the merge criterion, what kind of result do we get? We'll get the table shown below. We see that the Li Ming from Class 1 appears twice. Because when we merged, the system found 2 Li Mings in the right table. It matched one row with the first Li Ming and another row with the second Li Ming, which resulted in 2 rows for Li Ming from Class 1. The same thing happens for Li Ming from Class 2. The system found 2 Li Mings in the right table and created 2 rows. If there's one duplicate, the data will immediately expand into 4 rows. If there are even more duplicates in the actual business data, the data expansion could grow rapidly. This is why the system will remind you about data expansion and suggest that you deduplicate. Excessive expansion can cause various issues. For example, even though the data only doubled to 4 rows, if we later pull a report for the grouped data, Li Ming would appear as a superstar who scored 190 in Chinese, which is obviously not realistic or expected. So, how can we solve this? Some of you might suggest, since you keep talking about the merge criterion, we should add the class field as part of the merge criterion. That's right, this is one solution. By adding the class and name together, we create a unique merge criterion. This ensures that each Li Ming in the left table matches only one Li Ming in the right table. Thus, data expansion won't occur. However, depending on the actual business scenario, selecting multiple merge criteria may not be the best or even the correct solution. The specific handling of Cartesian products, data expansion, depends on your business needs. And you can refer to our relevant documentation for guidance. I won't go into further detail today. To summarize, the main features for merging multiple tables are vertical merging and horizontal expansion, such as adding columns from other tables.